Hello and welcome to this edition where we shall be exploring the sky and viewing option windows. So if you observe very well, this is my location and this is the time that I am recording this video. So in other words, this is afternoon. This is afternoon for me, so I cannot see the stars. But most of the things we are going to be exploring today is all about the sky and the stars. So we're going to turn off the atmosphere and sometimes we're going to be turning off the ground so that we can see the whole space. But for now, let's keep the ground and turn off the sky, the atmosphere. So we click on the window and we have this as our first, we have the sky here. So the first thing that we're going to see there is the Milky Way brightness, saturation or saturation. So it is used to make changes in the brightness of the Milky Way. This is the Milky Way there. And now I'm going to turn off the ground so that we can see the Milky Way in its glory. This is the Milky Way. So if I want to increase the brightness of the Milky Way, I'm going to do that from here. So you see the Milky Way increasing in brightness. If I want to reduce it, you can do that here too. So afterwards you can bring it back to its normal level. So that's about the Milky Way. Then we have the zodiac light. Is the is zodiac light brightness is used to make changes in the brightness of the sun. Oh, to make changes in the brightness of the sun. That's the sun there. So let me bring to the center. So assuming that I want to make changes in the brightness of the sun, I can do that from here. I just increase the brightness. I can reduce the brightness, or I could just bring it to the level that I saw it before. So this is used to make changes in the brightness of the sun. Then we have the dynamic eye adaptation. This functionality is used to dim faint stars in the background of any bright object. For instance, the faint stars behind the sun. So when you take this button, those stars will dim while the bright object will shine through. So let's demonstrate that. If I untick this, observe what is going to happen to the background stars. They will become brighter. So there you have it. They become brighter. But if I take it, um, they become dim again. So this is exactly how it's supposed to be. Even in our normal life activities, whenever you have a bright object, the 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 dim ones are to subside. Then we have light pollution. Um, to demonstrate this, I would like to bring back. Let me bring back the ground. Okay, light pollution. I would like to go. Let me explore it at night. Let me bring back atmosphere. Look at atmosphere. So the light pollution is used to is how much um your sky is when it comes to viewing the stars in the night sky. For instance, if you live in some places in the world, in some countries, you would notice that at night there's so much dust in the atmosphere that you can see the night skies, you can see the stars, you can only see the moon. So if you want to change your stellarium to be in that setting, you can do that from here. Observe that. Observe that I'm not going to do it. So you can increase the night pollution, the light pollution in your area, and you can see the stars again. This is Venus probably. Okay. It's a double star. So see, you can see the stars. This is night. This is nighttime actually because I've changed the settings to be nighttime. But if you can reduce it from here, this is zero light pollution. So you can, keep changing it until you get to the level of the kind of night sky you have in your location. However, if you cannot get it exactly, you can come here to make those changes automatic from the location database. So it will just use network to set it for you. Then you have the shooting stars. You can, if you want to know the, if you want to know the, if you want to know the frequency of shooting star, look at shooting stars. This is used to know the frequency of the shooting stars from your local night sky. Some part of the sky experience more shooting stars than the others. So this is just used to know at what part of the sky you might have the most shooting stars. You can have those shooting stars. So you can see the shooting stars there. So later you can bring it to its, you can bring it back to its normal level. So then afterward, let's explore the stars. So we have two scales. You have the absolute scale. Absolute scales used to increase the sizes of the stars in the night sky. So if I just click on it, if I click on it, the stars will begin to increase in their sizes and observe what's going on. And the stars will begin to, wow, look at that. So we have so many stars in the night sky, so many stars. Even those patches of the sky that you thought were dark and there were no stars, so you can see that there are stars there, but the only thing is that their sizes are so small that they're not so bright. So, but if you use this functionality, you can scale up their sizes so that they will become bigger. Later, you can bring it back to its level 1. But if you feel like you want to leave it at any level that you want, so you can. But I would suggest that you just bring it back to its original level, which is 1.00. Then this is relative scale is used to increase the brightness of already bright objects, celestial objects in the sky. So I want to increase like all these stars that are bright here. I want to increase the size. I can just use this functionality to do that. So they become even brighter. So you can take it back. Okay, can bring it back. So the major function of these two buttons is that we can use them to split two stars that are closely bound together like double stars. So there are a group of stars called double stars. We're gonna use this functionality to split them. Let's watch out double stars. Double star one. Okay, they are not in our horizon, so turn off the atmosphere, turn off the, and this is a double star. Let's bring our window to this side so that we can, oh sorry, double stars. Bring it to the center. Oh sorry. Double stars. So let's zoom in. So this is the double star. These are two star systems, but because of their brightness, you can't see them as double stars, but believe me, there are double stars and we can split them. We can do that by using this functionality, the absolute scale functionality. We can reduce their sizes. We can reduce their sizes, and you would see that they are actually double star systems. So I can zoom in. So you see, but I can also take it back and use these other functionalities. Let me take it back to 1. Then I can use this to reduce the brightness. See that? Can use that. So that's one of the major functionalities of this absolute scale and relative scale. Let me bring back the ground again. So the next thing is twinkle. If you want to make the stars to twinkle, already they are twinkling, but if you want to increase their twinkling rate, look at that. If you want to increase it, you can increase it. Wow, look at that. So you can set it to the level that you want. Then limit magnitude. It is used to limit the magnitude or the minimum brightness of stars that the human eyes can see. Like for instance, we have two terms that we use to describe the magnitude of stars in the night sky. The first is the relative magnitude and the absolute magnitude. So for the relative magnitude is how you would see the stars or the celestial object when you are standing in your position, in your local position on Earth. So that is how bright. So if you go outside at night and you see the night sky and you see the stars and you see the brightness that you see is described as the relative magnitude, and that is exactly what is being described here. So for the average human, the relative magnitude is 6.5. It is 6.5. So I don't think you should you should limit it. Just don't take it. Our stars is already twinkling, but we have spiky stars. If you want your stars to be spiky, okay, let me bring one. I want you want it to have the spiky features. You can use this functionality. If you want to remove the spiky features, you can do that. So depending on the one that you want. I think the two of them are good. The two of them are good. So you can remove the atmosphere. I want to remove the atmosphere so that I can explore better. Then you can show addition. Okay, label and markers. If you want to bring the names of the stars, um, you can increase it to bring out the names of the stars that you can't see or see their names. So this is used to you can remove all the names. None of the stars will have a name. You can adjust it to bring out some of the names. So I guess this is okay. Then we have the show additional star names. Let's see how that works. Uh, let's see how that works. We have this star for instance, and let's see what happens. Show additional. Use designation for. Sorry. Show additional star names. Okay. So this is the additional star names. I think it's okay. Let's leave it. Then this is use designation for screen labels. Um, if you look at this, these are the professional names that these stars have in astronomy, but they also have their local names, like the conventional names that we call them. For instance, for Andromeda Galaxy, we call it M31. This is the identity, the Messier or the professional name, but the conventional name is just Andromeda Galaxy. So this is exactly how what is playing out here. These are just the professional names. If you don't want it to be in that form, you can untick it, and the natural names they will just appear. The natural name of this subject will just appear, so that you don't need to stress yourself to find the name. It's just the name. So that is all about the star. So the next thing we're going to be exploring is the SSO. SSO stands for Solar System Object. Solar System Object. Um, and the first thing is that you can use more accurate 3D models. I don't fancy that, but if you want to activate it, you can go on. But I would like to explore the show planetary nomenclature. I would like to explore that. I want to see the planet first so that I think these names are much and I do like to minimize them. Wow, that's too much. So let me minimize them. I do like to see the planets. Where are the planets? Let me bring it back to show time to now. Okay, this is the time. Show time to now. This is my current time. I moved forward in time. So, and I would like to explore the solar system object. So, show planetary nomenclature. For instance, if I zoom in onto Jupiter, if I zoom in onto Jupiter, or say onto Venus, and as you zoom in, you would notice something. Look at all these names. These are the different parts of the planet that we have identified and maybe carried some level of studies. So this is the key to showing it. Show planetary nomenclature. If you untick it, there we go. For ticket, they will appear again. So you can do that for the planets. This is for Venus. I would like to do it for the moon because we have done a lot of work on the moon. So I want to see the different parts of the moon. See that different parts of the moon right there. This is the moon center. So it's a very great functionality. Then we have show orbits. You want to see the orbits of these planets around the sun. Show orbits. So take it. Take this one also. So any object that you click, the orbit will come out. If I click on Venus, uh, it will show me the orbit around the sun. Let me remove the ground again. So this is the orbit of Mercury. If I look at Venus, orbit of Venus. Okay, uh, Mercury. That's the orbit of Mercury around the sun. This is Jupiter. Oh, so you can't see it because Jupiter is outer. It's an outer planet, so you can. If you want to see the entire planet, you have to just zoom out. You want to see the entire orbit, so it's very, very large. It's quite large. So you can do that for, let's see, this is the orbit of the moon around Earth, not around the sun. So this is it, Mars. This is the orbit of Mars. But if you don't tick anything, all of them will come out. If you don't tick any planet, all of the orbits will appear. But you can also use it to know the orbits of the moons of Jupiter. Let's explore Jupiter, and these are the moons of Jupiter. If you want to, this is the moon of these Europa, Callisto. This is if you want to know the orbits of these moons around Jupiter. So this is just to know that. So if I want to come out, I want to explore. Let me set it again. Let me set it as well. Bring back the ground again. So we have you can explore what that means, but I don't think it has much value then, including this simulate light speed. And here we have it again, the light magnitude. You have it again. Don't change it like I said before. Then this is for the moon halo. It is ticked. Let's see what it does. Where is the moon? Let's explore the moon again. What the hell does that mean? Moon halo. I want to explore. I want to zoom in on the moon. If I want to turn it off, assuming that I turn it off, oh, it goes away. So you won't even notice that it's the moon without the halo. So you can put it back. Then you can do that for the sun too. And that's the sun there. You can bring it to the center. You have the sun. You can turn it off, and there you have it. There you have the sun's corona. I can turn it off. Let's zoom on the sun. You can turn off the sun's corona. Can turn it on again. Then we have the planetary markers. It is used to know planet because as these planets are right here, they look like the stars. So, but that marker will help you to distinguish between planets and the background stars. So you see a circle around um, planets, a circle around planets, and show you they are really planets. I guess you should just leave them. So circle around planets in our solar system. Then this is used to scale up the sizes of the moon. If you want to scale up the size of the moon, this is the moon right here. Move it to the center. If you want to scale it up, oh, I think I turned off the moon halo. Okay. Oh, so I want to increase the size of the moon. Maybe if you're not happy with the way the size is here, maybe you think it is smaller than you have it when you go outside. You can change the size from here. You can take that and start changing it so it begins to change in size. Uh, let me bring back the atmosphere. Okay. So you can also do that for the sun. There is the sun. Sun is somewhere there. You can change the size of the sun. So if you like, you can take it first before you start increasing the size of the sun. You can do it for the planets. If you think that the planets are too small or too big, you can reduce their sizes. Then you can also do it for minor planet bodies. If you want to increase the size of asteroids or comets or any other object that is in the solar system, you can make that changes from there. You can also use this to bring out all the heat, all the objects that are hiding in the solar system. So you can have Vesta, you can have Junos or asteroids. So you can use that to bring them out, or maybe you can just take it back. So that is all about solar system object. Then we have the deep sky object, DSO. So in here we have the catalogs. We have the catalogs. So like I told you before, catalogs are the way we identify stars and nebulae in the sky. So we have different kinds of catalog. We have the Messier catalog, which is this one. We have the card weight catalog. We have the new general catalog, and so on and so forth. But out of all of them, the most important are these three. One, two, three, four. Four. So let me just activate this one. So when you have this four activated, you would find most of the objects that you are looking for in the sky. So there's no need of taking all of them, okay? And also, one object can have multiple catalogs. So for instance, if you click on the Andromeda Galaxy, you will see other catalog IDs we use in identifying the Milky Way, sorry, the Andromeda Galaxy. Then we have the markings. So this is used to show some important lines in the sky. I'm not going to focus on all of the markings. I'm going to just focus on a few of them that are most important. And the number one is this one, cardinal points. Look at these cardinal points. We have south, we have southwest, we have west. If you want to remove them, maybe you don't want them, you can tick that, untick that, and it just goes away. But I guess you would need them, so you have to tick them. You understand? And if you do not want these intermediate ones, intermediate cardinal points, you can remove them by unticking. Personally, I do not want them, so I'm going to remove them. There you have the compass markers. You have the compass markers. It is surrounding your horizon. It is used to read off the angle when you want to identify stars in the sky. The position of stars using the grid lines, which I'm yet to explain, and I will do that in the next future video. Then we have the equator. The equator is simply the center, or like say it divides the Earth into two equal hemispheres, the northern hemispheres and the southern hemispheres. So it starts from the east, or maybe it cuts from the east to the west. So you can activate it, and that is my equator. I can also activate other important partitions. And this is the partitions that appear. Then we can give it numbers. Have this numbers hours. So this is the equator, and you should leave it. Then the next one we have is the ecliptic. Ecliptic is an important line in the sky because it shows the path where the celestial object in our solar system tends to follow. For instance, if you come out at night, you would notice that the planet seems to align in a straight path. And if you can even observe that from what we have here, look at the planets. We have we have Mars. Let me bring this down. We have Mars. We have Venus. We have even the Sun. They tend to follow a straight path in the sky. Although they have the individual orbit around the sun, but they seems to move uh, along a particular line called the ecliptic. So I'm going to activate it. If activated, oh, it's not appearing because of the color. Let me change the color to yellow so that we can distinguish it from the orbits of the planet. So look at the ecliptic. So you see, all the planet seems to move about this line. It seems to move about this line in the sky. So it's like it's like a reference line for them. So you can activate these other thick lines to give it some scale. Then we have the horizon. Horizon here. This is your horizon. You can activate that. Sorry, this is my horizon. If I turn off the ground, I'm gonna see that. So this is the horizon there. This is the horizon. So you can bring it back. So that's all about the horizon. You can take that, and I like to keep it. Then we have the galactic equator. Look at the. It is just the our galaxy, the bulge of our galaxy. Look at the line there. So if you would like, maybe you can keep it, but I won't keep it. Then we have the meridian. Meridian is the line that splits the Earth into two halves, east and west. And we have different meridian, but this one is about the Greenwich meridian because this is where we have zero meridian. So Greenwich zero. So it starts from the north and ends in the south. So let's activate it meridian. So then I can activate other ones. So these are the so we have activated the measure markings in the night sky that you should know. The other ones include the celestial poles. The celestial poles. You want to see the celestial pole? You can take that. That is celestial pole, the north celestial pole, and then you have the circumpolar circle. So the circumpolar circle right there. So all the stars that appear within the circumpolar circle would not go down in the horizon. They would just be moving in the circles. And you can use it to produce beautiful artistic picture. You can use them to produce beautiful artistic pictures. Then you can explore others. Okay, because we have lots of things to still explore in this video. So the next thing we're going to see is the landscape. The landscape. I can change my landscape to any form that I want. Look at the landscape here. Can change it to this one. Can I can change it to this one. Anyone that suits me. I can change it to anyone. This is the generic, the one we have by default. Then you can change it to this. You can change it to ocean. You know, remember in the first video when I was telling you that you can change your location, I also said that you can also change your landscape. So assuming that I change my location to somewhere here, see, I'm somewhere in the sea, and I can also reflect that in my landscape. I think that's the nighttime there. Sorry, let me change to a daytime. Sorry, daytime. This is daytime. So I can change my landscape to ocean. So so it shows I'm actually at the middle of the ocean. So I'm somewhere in the ocean, so I have actually changed it. So as you are making the changes here, you can actually change the landscape too. You can also change your location to look like you are from another planet. You can change your location and also your landscape. So assuming that I am on a Mars, on Mars, this is Mars, I can change my landscape to Mars to make perfect sense. So I've changed my world to from Mars, and I've just so this is how the night sky would look like if you are on Mars. This is how the sky would be. So if you're a scientist, maybe you're robots Mars, this is how it will look like, and it's so beautiful. See, this is the meridian of Mars, and this is the sun. All right, you can also change it to the moon. If you want to change your location to the moon, let's do that. Look at the moon, and let's want to see the bright side of moon. Then you can change the background too to reflect that. Uh, to the moon, the landscape of the moon, and look at that, so beautiful. Let me close this out. I'll come back to it later. And this is the moon. Wow. So look at that. Let's see. Let's explore. Let's explore Earth from here. Can we see Earth close by? Where about the planet? So this is the bright side of the moon. And these are the mountains and the moon. So let's search for Earth. So this is our Earth, and let's click on it. Wow, and it seems like it is below the horizon of the moon. So we have to turn off the ground so we can see the Earth clearly, and that's the Earth. So I'll zoom in, and that's our Earth. So we have such a very beautiful world. That's our Earth, and this is all right. So we can bring it back. Can bring it back, can bring the ground back, and this is the moon there. It seems like I have a neighbor. I have a neighbor. Oh, that's my colleague. Oh, we are astronaut. We are exploring the moon together. So you can explore other other places from the moon here. All right, so let's change it back to Earth. Let's change back to Earth, and West Africa. RGB. No, West Africa. Sorry, made a mistake. So this is it. Then I can change it back to a landscape before, which is this. That's the landscape that we had before. Hello? Assuming you want to add your landscape to Stellarium and you don't know how to go about that, how would you do it? And what you're going to click is here, add or remove landscape. From here you can do that. I did not specifically did it in this video, but I'm going to add another video for that where you can just see how they did it. But for me, I am convenient. I am comfortable with this landscape. But if you want to go extra mile to change the landscape of your Stellarium, you can do that from here. But you would need to go outside to take a kind of a 360 picture of your environment and then upload it here. We have a special way of doing that. So I'm going to attach a link um, to the description of where you can you can find that. So the next thing is the star lore. The star lore contains information about constellations. Initially we explored the Western kind of constellation where you have 8 constellation and 12 zodiac constellations. We have other constellation types. First of all, I'm going to turn off my atmosphere and the ground so that we can activate the constellations. So this is the Western kind of constellation that we saw before. And I told you that we can change it to other kinds of constellations from other cultures and religion. So let us go up. We're going to see, let me start from the beginning. Let's see the Arabic kind of constellation, how they visualize the stars in the sky. And you can see they pretty did a lot of work in astronomy. Look at that. This is the way they visualize the patterns of the stars. The way they visualized it. Then you can check on Babylonians. Babylonians. This is how they explored. This is the the kind of shape they saw in the night sky. Look at that. So you can continue on and on. Let's see the Chinese. Oh, they don't have any art. No art. Then we have Egyptians. Egyptians kind of constellation. Nothing much. Okay, then we can check Indian. The way the Indians explored. Look at that. So they have their constellation and the number of constellations are different. For the English or the Western kind of constellation, there is 88, but for other cultures, it's not up to that amount. So later on, when you are done exploring, you can return it to Western, because Western is the most widely accepted um, form of constellations in the academic world. So we're back there. So you can make some few changes. We show labels. Labels can go. So show labels. They can appear again. So show constellation lines. If you want to remove the constellation lines, then remove it and put it back. So that's it. You can explore other functionalities here. Then we have the survey. We have the survey. And this one is for another time. I don't think it is really that important though. So I would like to turn the constellation off. Then close this. Bring back my ground again. Position it well. So this is what we have. Then bring my atmosphere. So in the next video, we're going to be exploring the configuration window. Thanks for listening.